All right, so let's look at an example on how to solve a trig equation. Here I have 4 sine x cosine x equals 1, and I want the answer between 0 and 2 pi. All right, so the first thing I see is I know that I have an identity that is 2 sine x cosine x equals sine of 2x. I'm going to use this to solve the equation because it's going to make it a lot simpler. All right, so I'm going to break this 4 up as 2 times 2 sine x cosine x equals 1. The reason why I do that is so I can get this 2 sine x cosine x, and I can replace it with sine 2x. So I get 2 times sine of 2x equals 1. I'm going to divide by 2, and I'm going to get sine of 2x equals 1/2. I'm going to take arc sine, and I'm going to get 2x equals, let's say, arc sine of 1/2. All right, from here, I'm going to actually do a general solution. I know that I can get that arc sine of 1/2 is going to be at pi over 6 plus 2 pi k, and also at 5 pi over 6 plus 2 pi k. Now this is what 2x equals. So to solve for x, I'm going to divide everything by 2, and I'm going to say x equals pi over 12 plus pi k, and then here x equals 5 pi over 12 plus pi k, because I divide everything by 2. All right, now I have formulas that I can use to actually find my answers. And what I'm going to do is I'm going to use this fact that k is an integer. We know that k is an element of the integers. I'm going to start with the lowest integer. Well, not the lowest integer, but I'm going to start at 0. I'm going to go 0, 1, 2, 3, 4, 5 until I'm no longer between 2 pi. Well, I know I'm going to have to do 0 and 1, but I don't have to do 2 because 2 pi plus a positive number will be greater than 2 pi, and then 2 pi plus a positive number will be greater than 2 pi. So I only have to do 0 and 1. So I'm going to do pi over 12 plus pi times 0. Well, this is pi over 12. And then I can do pi over 12 plus pi times 1, which then is going to give me 13 pi over 12. Then I do it here. 5 pi over 12 plus pi times 0. This gives me 5 pi over 12. And then I do it for 1. 5 pi over 12 plus pi times 1. This gives me 17 pi over 12. And those are my 4 solutions. So I'm going to write them up here. I'm going to get x equals, I've got pi over 12, 5 pi over 12. I have 13 pi over 12. And I have 17 pi over 12. All right. Now, this is one way to solve it by getting the general solutions, writing a formula for x, and then plugging in integers to make it work within the bound. Now, what I'm going to do is I'm going to show you another way to do this with what we call change of variable or u substitution. All right. So I've gotten rid of everything else. I'm back to this step of sine of 2x equals 1/2. Everything else you do in u substitution stays the same up to this point. Now, I'm going to just go ahead and say, hey, you know what? Let's let u equal 2x. So that allows me to write this as sine of u equals 1/2. This is a simple trig equation to solve. This is pretty straightforward to solve because we know that we're going to have pi over 6 plus 2 pi k, and then 5 pi over 6 plus 2 pi k. Those are my general solutions for this one. So that's pretty straightforward. But the key to this is, if I've changed the universe that I'm in. Here I'm like in an x universe. Here I'm in a u universe. This bound between 0 and 2 pi is for x. So I need to find the bounds for y, for u. The way I do that is I'm going to take my x bounds and I'm going to plug it in here. So u would equal 2 times 0. That gives me 0 is my lower bound. And then my upper bound for u is going to be 2 times 2 pi, which is 4 pi. Now I do the same trick here. I do pi over 6 times 0. My answers are going to end up being pi over 6. And then when I put 1 in here, I'm going to get 13 pi over 6. Here I'm going to get 5 pi over 6, and then I'm going to get 17 pi over 6. All right, so these are my answers. This is what u equals, but we know u actually equals 2x. Well, I can divide all of these by x, and guess what I get? Pi over 12, 13 pi over 12, 5 pi over 12, and 17 pi over 12, which are the same answers we got the other way. I don't care how you solve it. If you do u substitution, just be careful. You can't have x's and u's in the same equation, and everything has to be the same, so it can get fairly complex. But I wanted to show you this because we are in a pre-calculus class, and this change of variable, changing the bounds, comes up in calculus. So you can kind of already start seeing that you can change the bounds whenever you're doing a change of variable to help you in your next class. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.